Alright, today I have a bit of a repair and I'm going to see what I can do with this. This is a jukebox, or at least the top half of it, the amplifiers in the lower half. And there's a wire running down here, which I can see, which I can't really fish out very easily one-handed, but there's a linear regulator and a Molex plug in there that goes up to a cooling fan on the side. The cooling fan is hiding in here, and we'll pull the wiring out, but the wiring is very heavily melted. So we need to pull that out to find out why the wiring's melted, and then look at possibly replacing that fan. But this should be a fairly simple one, but we'll walk you through it once we get that fan out. Okay, well, I've managed to extract the fan. Now I see what's been done here. So we were connecting the video distribution amp in the back of this using a 9-volt regulator, a linear regulator, which I'll have to reconnect. But also the fan was coming off the 12-volt side, and clearly it's had a short circuit somewhere. I'm not entirely sure where, but it's melted the wiring. So yeah, we're going to put a new fan on for a start, and I'm going to use some heavier wiring, I think, and find out how that's all meant to work. But yeah, I think we need to find another 9-volt supply somewhere. Anyway, yeah, let's go. We're going to trim all this off and we'll dig out another fan out of my collection. Alright, so I found another 80mm fan in the collection. This one's the same width and dimensions, however probably a little bit higher rated. This one's a 0.2 amp. This is a 1.4 watt, which is about 250 milliamps. I'm going to have to look that up actually. I'll do some maths in a bit, but I think Ohm's law is 12 watts at 12 volts is 1 amp. So let's bring up a calculator over on the computer up here. So 12 watts at 12 volts is 1 amp. So if we go, what is it? 12 watts. Yes, so 12 divided by, geez, my brain is not on the ball today. 12 divided by 10, that means it's, oh, I've got the thing on the wrong spot. Do one thing at a time. Right, so 1.2 watts per 100 milliamps. So that makes it about 150 milliamps, somewhere about that. That's right. So the first thing we need to do is check if this thing works. So we have, off the side here, we've got some clips. Let's juggle everything around. Let's angle our camera over here a little bit. Let's see if we can do this. I'm playing with a new tripod system. So let's shove into our 12-volt output, which at the moment it's about 14.3 volts. But I know these fans are voltage tolerant enough to handle that. Let's clip on our fan over here. Let's give ourselves some, yep, we are working. Let's put some wind noise. Okay, so it works all right. That's good. So I want to diagnose this fan and see if it's had a dead short. So let's just snip these off. We'll find out if this fan still works or if our problem has come from somewhere else. Let's bring our camera angle back over. New tripod, guys, so I'm still getting to the hang of the... Okay, one thing that's happened with MS is multitasking goes out the window. If I'm doing anything with my hands now and trying to talk at the same time, I start to lose track of my words. That's why you'll find there's so many grammatical errors in my wording. Well, this fan appears to work just fine. I'm noticing as I move it, I can feel it change. There's a vibration there, it's smooth in that position, it's vibrating there. He has said it's been making some noise, so I think this has done so many hours that the bush has died. So I'll replace it anyway, but the short circuit is clearly not with the fan, which makes me worry. Although this is very thin, crappy wire, I think the short might have happened where it's been the hottest, which is here, but I don't know, and that's concerning. Considering this is on a computer power supply with a usually got a short circuit detection, it'll shut it down. But anyway, I need to get these pins out and I need to connect back onto the 12 volt again. I might even do it off this adapter this time, and I'll put a fuse in here. I think it would probably be wise looking at this. So yeah, for a start, these are going to get snipped right off because the whole length of that cable is now useless. So yeah, and we'll just, I think we might even just splice in between these two, might be the easiest way to do that. Yeah, I think that's what we'll do. And we'll get a new length of wire for the fan. So let's get everything prepared. So we've got some tools here. We're going to throw that away. The only value in that was determining if we had found the fault. I'm going to back it in that this regulator is probably perfectly fine. I will test it, but I think I'm just going to get a couple of heat shrink sleeves, solder filled heat shrink sleeves, and just reconnect that. It's possible, because I've worked on this machine many years ago, that might have been a bodge job I did temporarily 10 years ago, and not quite up to the standards that I do these days. So yeah, we might I might rethink that and do it properly, especially considering we've had a short out, and that is the risk with doing temporary jobs. So I'm going to use automatic strippers here, but a little trick: if you're gentle with these, you can pull the wire out like this in the middle, and we can splice to that. So 12 volts is on the yellow and black, and I'm going to offset these just slightly. That is the risk you can run if you're too quick with this, but it's not the end of the world. But anyway, I was going to offset them slightly so that chance of a short circuit is minimized. But I will be putting proper heat shrink on this to help insulate it correctly. Right. So now we're going to heat up our soldering iron and get our new length of wire prepared, and we'll solder everything together. Before we start, I'm going to thread a little bit of heat shrink tube onto each one of these, because the thing I always forget is putting my heat shrink in the right spot. And actually, a new tool I've got, normally I'd use a cigarette lighter for this, or like a stoner torch like I've got, but I've got a hot air gun now, and that works really well, so I'll probably use that. Anyway, now we've got that done, we're going to strip the ends. Now I've moved my marker out on this to give me a little bit more length. That's what that orange piece is for, is to set the length that you strip. Most of those that I've had in the past haven't had that bit, so I'm still trying to decide whether it's worth it or not. Alright, let's get some blue tack out and get this prepped for soldering. Alright, so we're prepped for soldering. I'm going to wrap this one around a little bit, get a good loop here. I'm not sure the heat shrink's really going to do the job in this case because I'm splicing, but it's here nonetheless. For this piece, actually, I'm going to change the game plan slightly. The ground wire is not so much of a problem if it's not insulated. It's good practice to do it all the same, but the one we're really concerned about is the 12 volt hot wire here, which I haven't really left myself enough room for heat shrink. But we're dealing with a cock up here, so in an ideal world I would be fitting new Molex connectors to this and doing this quite properly, or I'd have a pin removal tool which I need to buy, and I'd be using that to remove the pins and crimp on a new set. So I think I might pre-tin them and I'll attach them that way. In the meantime, I'm going to need to bring over my fume vent, which means I need to remove an ID tag and some keys here, and I need to bring this over to a hook right above this area. I've got another visitor. It's Tinkerman Mick. We'll see him in a moment. Tinkerman Mick was just dropping back some stuff he'd loaned off me. Good man, that guy. So, I do like to loan things to people that are inclined to return them. It generally makes me more inclined to do that again. Let's get our soldering iron in on the job here. I'm going to heat this one up. So, it's a bit of a tricky job, but I've got some heat in there. Test all that in a minute. I'm going to tin these two together. This is going to be a tricky join in the way that I want to do it. and I can probably hear a lot of people in the background here if my videos ever get a lot of views. I actually hit 100 subscribers last night. But yeah, if my videos get a lot of subscribers, I can imagine that somebody's going to troll me about my techniques. And this is a very short-term fix immediately before Christmas. Afterwards, this guy's going to bring it back to me, and we're going to actually do some proper engineering and do a proper fix for this. So let's solder these together, and we'll put some heat shrink over it. And yeah, blue tack is magic for this sort of stuff, I have to say. Look at this. Joined a nice inline splice here. Alright. That looks like that's going to go over. We'll get a heat gun into it, and this, I'm going to have to be forced to put a bit of insulation tape on that, but at least we've got heat shrink on one of them. So let's see if I can get my heat gun up to speed over here. Let's pick this up. Let it come up to temperature. It's already pretty hot. That's my UPS complaining about being overdrawn because it's on the 1000 watt output. In any case, that's all I needed. That's wonderful for doing heat shrink, that thing. Alright, so we'll put a little bit of insulation tape on this, then we'll attach the fan to the other end, and then we'll test our regulator, see if it's still doing the thing. Now it's time for the fan end of the cabling. So this is sort of an embarrassing look. It looks like I've just mashed tape on and twisted it together, but we know there's proper heat shrink under there and everything. And I did individually insulate the ground wire as well, so don't get too worried about that. But again, it's a temporary fix. We'll be doing a proper fix in the very near future. So this wiring I like. It's a good diameter for working with these automatic strippers. One of the reasons I'm using these now is my old method of using these cutters, whilst very effective and you have a lot of control, because of my MS, the dexterity is sort of dropping back a bit, so I've been forced to use other methods. Now you'll notice I bent the wire here. This is just to stop the heat shrink tubing dropping off the end while I hang that across my lap off camera. And that's just for convenience sake. I've already trimmed and stripped these, so I'm going to try and get an inline splice here, and now we need to make sure I wired these up the right way. I'm sure I've used the black trace as ground, but I've been caught before and made mistakes. When I'm trying to film stuff, it's a good time to do that. So I'm just going to double check my work. Where are we here? We have a continuity beeper. Should be audible continuity beep. Why is it not working now? One of my probes is dodgy. I have a dodgy probe. And this, ladies and gentlemen, is why you test before you actually use the machine. Because you can go, yeah, there's nothing on there, and then you can find there's a dangerous voltage on there. One of these ground wires should be the one. Right, yep, black trace is indeed ground. So, we've avoided another wiring smoke up at least. So now we piss that off out of the way. And I'm going to try and get these into a nice inline join instead of just a dodgy looking twist. I'm going to need a little bit more wire exposed, and for this one I'm going to use the old method of sharp cutters, a gentle squeeze and a bit of precision. I can't always do that, and I'm a little bit shaky today, but that's the way I always used to do it. I just have to concentrate a lot more on doing tasks like this than I used to. Okay, so haven't lost it. Where's our black trace? It's our black trace. Let's run you around like this, and we'll clean this up after we solder it. Stick on the blue tack, and I'm sorry if the camera angle's a little funny right here, but we'll get this one done. We'll do the other one. If I've done this right, they should be both the same length and they should fit the heat shrink nicely. So let's chuck you right there. Do the same thing here. Alright, so there's our bits trimmed off, and it's important to do that so you don't get bits hanging off through the side and touching each other. Alright, so here's our heat gun again. My UPS doesn't like it. I'm running half my desk on one output from the UPS, and it's only good for 1000 watts. Although at the moment I'm pulling about 850 watts, down to 650 now. If I hang that up, we're dropping back to 343 watts. So I just hooked up the old fan. Yay. Well, you've got a good job. I'm just going to cut this film. Imagine I did this to the right fan. This is what I'm talking about, getting distracted when I'm filming. We'll be right back. Okay, well the other fan is on. We've got nice clean little inline joins. We do need to test it though. Now, I wonder if these little hook clips are going to do the job for me. Well, they're hooked on bits underneath the desk because they're hanging down there. Let's, one of these will be ground, any one of the center pins, and our 12 volt pin is yellow. Dexterity is a bit funny today, I'm fumbling with this clip. Alright, well our fan is spinning. That's good. So next order of duty is to check our, I think this will be a 7809 regulator off memory, if my memory works that well. I'm going to strip these off and I'm going to chuck a voltmeter on them and see how much it's putting out. Alright, we have our voltmeter on the 20 volt range. So I'm pretty sure this was 9 volts. I could probably just crawl under the device and check the rating. Now let's actually stick these down on the blue tack so we don't have a short circuit. Although the LM78 series regulators aren't too bad at short circuit detection. They will have a thermal overload built into them. I need to stop talking while I try and do fiddly things. Hey, I'm fiddling. Okay, they were hooked on. So let's touch this on the 12 volt and see what we get out. 8.76 volts, that's close to 9. It's about what I would expect. A little low, but it's also not under load. It should level out. That does say that that regulator may have had a bit of a hard time. But anyway, we'll try that out because I'm pretty sure that the video distribution amp is pretty voltage tolerant. Oh, the other thing I needed to do was check the polarity on that, but I think I can check my video and find that out. Anyway, let's move on to reattaching this. Alright, well the fan's back and installed except for 2 nuts that I'll put back on in a minute. And we're getting power supply through it, so it's working well. The fan's running, no smoking wires, it's all good. I think where the problem might have been, these 2 wires were connected to it too, and they go to a socket on the rear of the unit which supplies some LED strip lighting on the lower half, and the plug on that has also been damaged. I think maybe the plug on the other section's been tripped over, it created a short circuit, and this being parallel with the fan might have caused that short circuit. And these wires have been, you can see how they're stuck together a bit, they've clearly been warm as well. So I think the problem has been with an external short, so the fuse is probably going to go on this as well. But yeah, anyway, I've got to hook these up and we'll do another inline splice. And of course this unit is based on Windows XP, which is great. I'm going to have to force shut it down, which I can do this way. There we go. Alright. Alright, I've got some forestry chatter going in the background because I'm listening to the fire tower channels, as I was a fire tower operator for 8 years and I'm curious to see who's got my position now. Anyway, what are we up to now? Well, this is the output that drives the LED stripping on the other half, and I've got it connected to a calibrated lead, if you could call it that. I've got a little pin prong here that tells me which is positive and negative. I'm on the 20 volt range on the meter. I'm going to fire this up now and see if the polarity is correct on that pin, because the wires are a bit ambiguous. So let's put an illuminated output on this, turn power on here, and we push our start button here. See what we get. 12.3 volts, and it would appear to be center positive, which is good. That's what we like to see. Now I'm going to force shut it down before the OS fires up, so we don't corrupt any disk, because it is technically a computer and motherboard in there. This is a video amplifier I put on here like 8 or 10 years ago or something like that. I don't recall when, but a long time ago. And also 3D printed this nice little cable entry in 2 sections, like a clamshell. Alright, so actually if that was 3D printed, that would have been around about 7 to 8 years ago. That's when I first got them, and I was still using that transparent PLA that came with the printer. So this is pretty much it. It all works. So I'm going to give the guy a call and give him his jukebox back again. But yeah, unlock everything up with these tubular keys, and then clean up all the mess on the floor. Alright, so now it's time to clean up my desk. I've got to clean up all of this. This happens weekly, but you know what they say, I don't know what they say. It's a dirty desk, I need to clean it up. I'm going to go do that, and I'll see you guys in the next video.